All right, I got to thinking on my way over here that you don't need that. Where the heck is the paper? Oh, here it is. Here we go. That I would give you three problems, all right? And I'm gonna of course post these on Canvas for you all. But three of those projectile motion problems. All right. I don't think you're gonna have problems with any issues with the forces because I just wanted to introduce them and how Newton's three laws and all that kind of stuff works. But here's three examples of problems. So let's look at, I'm going to make three videos of each one, and I'll also provide the solutions, that I'm working on here. Now, I am flying without a net here. I haven't worked these out, but I pulled them from an old textbook, and they look like nice problems. Now, these two, so if we read this one, a supply plane is flying at an altitude of 1,050 meters at a constant velocity in the positive x direction of 115 meters per second. It releases a package from under the belly of the aircraft, which is the same thing as someone throwing something horizontally. Calculate the time the package was in the air, and calculate the distance it traveled along the x-axis before striking the ground. And it would be right, if the plane didn't change speed, it would fall right below the airplane. All right, and calculate the magnitude and direction of the velocity of the package when it struck the ground, just like we did in class today. Now, these two problems are a little bit different. Same thing, but there's implied tasks that you have to do to be able to solve these, and that's part of doing physics. I'll tell you, I'll be right up front with you. Your question's going to be more like this on the exam, but it says, but on this one it says, but if you can do these two, then you're golden for that. As a tennis ball is struck, it departs the racket with a horizontal speed of 28 meters per second. Okay. And you know that it's never going to change that speed, right? And the ball strikes the court. Okay, so here we've already calculated the range. And we know it's going to be 28 times the time is equal to this. Hey, how far above the court was the ball when it was struck? Well, we can use this. We'll do all that. We'll do that one too. All right. So again, it's implied we got to find it. Well, I don't know. How do I find the time? But you know the range and you know the initial velocity in the x direction, which stays the same, so we can find the time pretty easily. A horizontal rifle is fired. This is kind of more of the same thing. The muzzle speed is 670 meters per second. It's a horizontal thing. The rifle is pointed directly at the center of the bullseye, but the bullet strikes the target 0.05 meters below the center. What is the horizontal distance between the end of the rifle and the bullseye, or the range? Okay, so here, this in problem 2, we found the range. We want to find the height. Now we're given the height of how far it fell. That's the implied thing here, and we're going to use the time thing to find the range. And a couple students came up, and I'm going to show you a different algebra because they're going, wait, G is negative, and I got a negative in my square root thing for the time. I'm going to show you, if we really take our time, how that cancels out, because it was a great question, and we just didn't have time to. So there's your intro, and let's look at problem 1 in the next video.